All right. So here we are going to continue with 1A.3 rates of change, linear and quadratics. So as we go through, please remember you know most of this, okay? So we're on 1A.3. Ignore that I wrote that weird. Notes part 2. As far as the assignment goes, the new word of the day is concavity, okay? So we're going to be looking at concavity. In a quadratic function, we can determine the curvature or the concavity of the graph by considering their average rate of change over equal lengths x interval. The key word here is equal lengths x intervals, okay? So make sure you take note of that. So sketch slopes at each point on the graphs shown below. So when we sketch the slope, we are just, me trying to go through the line. I did not mean to go through the line, but notice how as you're sketching the slope is increasing, right? It's getting steeper and steeper and steeper. On this side, we are, that didn't get very close to that. I can't pretend that that's okay. It is, guys, I don't even know why I'm not using my pen. I was using the mouse. Silly me, silly me. Okay, notice that the slope is decreasing. It's getting steeper, but at a negative incline, right? So the curvature we're analyzing is how is the average rate of change at a given point changing. And that's what we're determining when we say concave up or concave down. So concave up means that your slope is increasing. Concave down means your slope is decreasing. So when we wrote this, we talked about that concave up, the average of change over equal length input value interval is increasing for all small length intervals. The word rate is definitely missing. The average rate of change over equal length input value interval is decreasing for all small length intervals, okay? So that's what happens when it's concave. Then we went over example 1, and I had you find the rates of change from each one of these. So remember, finding your average rate of change is the change in y divided by your change in x. So just reiterating what you did for each one. So for the first one here, we found the rate of change, not the change in y. So for the first function k, if I was to find the change in y, the change in y is 1 minus 4, which is negative 3, over 1.1 minus 1, which is going to give me 1/10, and this equals negative 30. And that's how we found the rate of change, and we did this repeatedly following the rule of average rate of change equals the change in the y divided by the change in the x. So again, we found the change in our x and we found the change in our y. Now what I want to highlight is that, again, it has to be over the equal length intervals, x intervals. So notice that to get from here to here, it's 0.1. To get from here to here, it's 0.1. To get from here to here, it's 0.1. On the next table, same thing because we're using the same values. It doesn't matter about the y's, it matters about the x in order for you to analyze whether it's going to be concave up, concave down, or neither over the given domain. So putting it all together, when you are describing functions, there are many vocabularies and attributes that we look at. First is it an increasing function? When your assignment the other night asked you to describe, is the function increasing, okay? When you're describing whether a function is increasing, you're analyzing the y values. What are your y values doing from left to right? So as my x values are increasing, my y values are increasing. So this is an increasing function. Over here, we have a decreasing function model. Again, you're looking at your y values to determine what's taking place because you're analyzing decreasing. As you read the function from left to right, what is happening? As the x values are increasing, my y values are decreasing. Therefore, this is a decreasing function. Okay? And this is what this is saying in the formal sentence. And a formal, well, very formal sentence. Next, when you're describing concavity, you are analyzing the rate of change, okay? You are analyzing the rate of change, apparently. Oh, that's not a good color either. Let's try, maybe green will be better. rate of change. Okay, if your rate of change is increasing or decreasing is what you're paying attention to. So when you're reading this graph, we are going from a negative slope to a positive, to a constant slope to a positive slope. So this is concaved up. Okay, on this one, so again, it's our AROC that we're analyzing. So it's the change in Y over the change in X that is being analyzed from point to point. Okay, and it's increasing. And then concave is this is decreasing, and it's decreasing because overall the rate of change is decreasing. We're going from a positive slope to a constant slope to a negative slope, and that is why it is decreasing. All right, so finding the equation of a secant line. So when you're looking for the equation of a secant line, you have y equals mx plus b is our primary mode of making sure we understand the equation of line. This is your end game. This is what you're trying to write it as. So making sure that you get it down to y equals mx plus b. In order to get down to that, we're going to be using the point slope form. The point slope form that I want you to focus on is where y is already isolated. And all we did was add our y1 to the other side so that our y is already isolated. Okay. And then so then for this problem, it said find the average rate of change of g from, and I should have written this as G and G because it says G. The graph is called G. Of G from -1 to 3, right? So the first thing we're going to do is find G of -1. So I need to figure out what is the output for -1, what is the output for +3. So the output for -1 is -4. You either can use the given function or you can use the graph. When I go to -1, I get -4. When I go to +3, I get +4. So these are my input and outputs for -1 and 3. From there, you then are going to find your average rate of change. Remember, your average rate of change, again, is the change in your y over the change in your x. So the change in my y, so 4 minus -4 became 4 plus 4. Over the change in my x, 3 minus -1 became 3 plus 1, which left me with 8 over 4, which equals 2. So that is my average rate of change. My AROC is 2. Okay. From there, we're going to find the equation of the secant line containing the point. So in order to find the equation of the secant line, that is where we're going to be using our point slope form. We use point slope because we have our slope, our AROC, right? And we have our x1 and our y1, which could be either one of these values to plug in. I typically choose the smallest numbers, which is why I substituted in. So for my slope, we put in 2. For my x1, we put in -1. And for my y1, we substituted in -4. So after I substituted those values in, we then went ahead and evaluated. Simplified, I'm sorry. We went ahead and simplified. A negative times a negative is a positive. After we simplify, we then distribute. We distribute 2x, and we got 2x plus 2. And then we combine like terms. After we combine like terms, we were left with y equals 2x minus 2. So therefore, our equation of our secant line is y equals 2x minus 2. So that's the line that I would draw to connect between -1 to 3. So I'm going to go to -2. At -2, I rise to and go over 1. That's following the slope. Rise 2 over 1, rise 2 over 1. Notice how I'm going to touch that one. I fall and I crawl, I fall and I crawl. And so now we're going to, nope, I was going to tell you to pretend that is the straightest line you've ever seen, but I couldn't even lie to myself in that instant. So I'm not going to expect you to. Let's try it from this angle. Yep, she's going. And boom. Bam. All right, and there is my secant line for my graph. So this is my secant line. It's the line that is connecting -1, -4 to 3, 4 from this quadratic model. All right, so here is your turn to try and to practice, but it starts off with you finding the missing value in the table. So helping you set up, if I'm finding the missing value, this is my unknown y. I have no clue what this y is, but I do know that I'm going from 0 to 4, okay? So, and it tells me that my average rate of change is 18. So I know that a roc equals 18, and 18 equals my y2 minus y1 divided by x2 minus x1. So knowing that, I plug in what I have, right? So if I'm looking from 0 to 4, I'll just let this be my y2, and I'll let this unknown be my y1, which means that this is my x2 and this is my x1. Notice, again, as long as they're paired, it does not matter which is your x2 and your y2 and your x1 and y1, as long as they are correctly paired together as x and y. All right, so I have 2 minus y, because I don't know that value, over 0 minus 4. And this has to equal 18. So I'm asking myself to evaluate what y is. So that's what you're going to find is what y is. Once you have found y, you then can go ahead and substitute in for h of 18 because you'll know what that value is. And you can practice finding your secant line. Remember, finding the secant line, we're using y equals m times x minus x1 plus y1. Okay? You got this. It's going to be great. And yeah.